Hey Alex, so I'm just going to go over a selection of the questions that we done the other night, just the trickier ones. So in particular, it's going to be this functions integration question, and then this one right here. Followed up, we're going to have the coordinate geometry of the circle questions, and then we're going to just do the first one of the complex number questions. So I'll start off with the first one there. So question 6 says f and g are two functions of x which are elements of the real numbers where f of x is equal to 6 plus, or x plus 4 and g of x is equal to x squared minus 2. Part 1, find the two values of x for which f of x is equal to g of x. So we need to equal the two of them to each other. So if you see something written like this, you can literally just replace this with x plus 4 is equal to x squared minus 2, and then we're going to solve. And we should get two values. We might get one, but we should get most of the time two. They'll rarely do it, so you don't get any of them. So we do this, we're just going to have x plus 4 is equal to x squared minus 2. Bring everything over. X squared minus x minus 4 from both sides minus 6 is equal to 0, and then just factorize. So we're going to have x, and over here we're going to have 3 and 2. Now we need to look at the combination. So we know if we have negative 3 plus 2, we'll get this negative 1 in the middle, right here. So they're the two we're going to have to use. So it's going to be x minus 3 multiplied by x plus 2. And if we do that, it'll give us our original function here. And now we just need to, so we have x is equal to 3 and x is equal to minus 2. And then these are going to be your two answers. Not too hard to get started. So next up it says, find the area of the shaded region in the diagram below, not to scale. The region between the graphs is f of x and g of x, from x is equal to negative 1 to x is equal to 2. So we're finding the area under the curve, and it's bounded. We're going to have to take one from the other and go from there. So if we do it this way, we're going to have to do f of x minus g of x. I know it's written there, but just to simplify it. So it's going to be f of x subtract g of x, and then we're going to find the integral of that. So if we do that, it's going to be the integral between minus 1 and 2 of f of x, which is x plus 4, minus g of x, which is x squared minus 2, dx. And if we do that again, integral to negative 1, we're going to have minus x squared plus x, and then we have 4 minus minus 2, which is plus 6 dx. Now we just need to do the integration of this, so we're going to have minus x cubed over 3 plus x squared over 2 plus 6x, and then we're going to have to evaluate that between negative 1 and 2. And if we go ahead and do that, it's going to be minus 2 cubed over 3 plus 2 squared over 2 plus 6 by 2. And we're going to have to take away minus 1 cubed over 3 plus minus 1 squared over 2 plus 6 by minus 1. And if you just stick that all into your calculator, you're going to end up with 33 over 2 units squared. So not too tricky. The next one though looks intimidating. All we have to do is just treat this as a regular number, especially this be to the bx. It's just a number. So it says b is an element of R, is a positive constant, and evaluate the integral between b and 0 of be to the bx dx due to e. Work out the value of b. So we're going to treat be to the bx as a number. And by that I mean you do what you normally do. So for example, if it was 2e to the bx, that's not intimidating. All we're going to be doing is integrating the e to the bx. And then whatever that comes out as, multiply by that. Same as you always do. So if we take be to the bx, we can kind of forget about that. So I want to integrate e to the bx. And if we integrate e to the bx, if you follow your logs rules, we know that the integral of a to the xn, well, that's going to go to 1 over, I should have said nx, sorry. 1 over n a to the nx or xn, whatever. So that's the rule. So this now becomes 1 over b e to the bx, and we're going to plug that straight back in. So the integral between 0 and b of be to the bx dx is equal to e. Well, that becomes 1 over b times b to the e to the bx evaluated between 0 and b equals e. But if we look at this first part here, we're going to have 1 over b times the b, so we're going to just get 1 there, so they effectively cancel each other out. So now we know that e to the bx evaluated between 0 and b is equal to e. Now, if I just move this over, we can go ahead and solve this. So, if we sub in b, we're going to e to the b times b minus e to the b times 0, and that's going to equal to e. So we end up with e to the b squared minus anything to the power of 0 is going to be 1 is equal to e. Simplify this, e to the b squared is equal to e plus 1. Now we're nearly there. All we need to do now, wrong tool. All we're going to need to do now is just follow your rules of logs. So if we want to get this power or this b down, we can take the natural log of both sides. So what we're going to do is we're going to take the natural log of e to the b squared, which is equal to the natural log of e plus 1. What happens when we do this? Well, when we do this, what we're able to do is bring this b squared to the very front. So what we end up with now is b squared times the natural log of e is equal to the natural log of e plus 1. You can check in your calculator or whatever, but if you find the natural log of e, that's just equal to 1. So this is equal to 1. So we just end up with b squared is equal to the natural log of e plus 1. And now all we need to do is take the square root. So b is going to be equal to the square root of the natural log of e plus 1. And when you type that into your calculator, what you end up getting is 1.1459 ... So in the end, this is your answer. Most intimidating part here is because there's a b here. Treat it as normal. Take out this constant at the very start, which tells us it is. Just integrate the e to the bx, figure out what that is, and then you can see there's a lovely bit of cancellation going on here. So now all we have to do is figure out this. And from here, it's just plugging in b, plugging in 0, figure out what you get. Then we just need to bring this b squared to the very front using logs, and then we end up getting to our answer right here. Now, it says the circle C has equation x minus h squared plus y plus 3 squared is equal to 12, where h is an element of r. Write down the center and radius of the circle. Give your answer in terms of h where appropriate. So when it's in this form, we know that this number right here is equal to r squared. So to find r, we just need to take the square root. So we know the radius, square root of 12, and the centers are going to be right here and right here. So it's going to be h minus 3. Now part 2. The perpendicular distance from the line x minus 4y plus 7 is equal to 0 to the center of the circle C is 5 units. Work out 2 possible values of h. So perpendicular distance, we're going to need that formula. So this is going to be the absolute value of ax1 plus by1 plus c all over a squared plus b squared and the square root of that. And we know that this thing is equal to 5 units. So write everything out. We have x minus 4y plus 7. So we have our a, b and c, and then we have h and minus 3 from the last part, which is our x and y. Plug everything in. We're going to have 1 times h plus minus 4 times minus 3 plus 7, absolute value, and that's all over a squared of a squared plus b squared. So it's 1 squared plus minus 4 squared, find the square root of that, and again equal to 5. So if we simplify this, on the top we're just going to end up with h plus 19, still absolute values, over the square root of root 83 root 2 should be square root of 1 squared plus 4 squared root 17, sorry, equal to 5. Multiply the root 17 across, so then we're going to have the absolute value of h plus 19 is equal to 5 root 17. So this is how we're going to find it. To get rid of an absolute value, we just square both sides. So when we do that, we end up having h plus 19 is going to be equal to, well, we can square both sides, or what we can see is that this is going to be equal to 5 root 17, or h plus 19 is equal to minus 5 root 17. Why is it that? Well, it doesn't matter if we have x or minus x. When we square both of them, what we end up having is x squared or x squared. So even though it's positive and negative, when we square it, it has to be positive. So we just take both of them. So it wants us to leave it in third form. So now we just have h is equal to 5 root 17 minus 19, or h is equal to minus 5 root 17 minus 19. Both of these are your answers. You have to have both of them. You won't get full marks without it. Now, it says the circle S passes through the points 8, 1, A3, and A minus 5, as shown in the diagram on the right, not to scale, where A is somewhere greater than 0 but less than 5. The radius of the circle S is the square root of 20. Find the equation of the circle S. So, we're looking for the equation of a circle. X plus h squared, or x minus h squared, sorry, plus y minus k squared, e to r squared. Tells us the radius here. So we know that r squared is equal to the square root of 20 squared, which is just 20. So that's going to be our radius there. Now, another thing to note. Because we have an A here and an A here, the midpoint of these two lines, or the midpoint between here, so somewhere here, is going to be where the center of the circle lies. So if we draw an imaginary line right about here is going to be the center. More importantly, the y component is going to be the midpoint between here and here. So if we add the two of them together, we're going to have minus 5 plus 3 gives us minus 2, divided by 2 is minus 1. So right here, this is the point minus 1. And this right here, this red line, the equation of this is going to be y is equal to minus 1. That's all it is. So we can already fill out that we're going to have some value h for our center, and then minus 1 for the other one. And we're going to use this to figure out everything else. So what else does the question tell us? It says the radius is equal to root 20. So any point or any line drawn from the center to any other point on the circle, we know for a fact that that distance is going to be the square root of 20. So we can use this fact and the distance formula from h minus 1 to figure this out. Easiest way to do it is just going to be using that point 1. So again, we're going to have to find the distance, which is x2 minus x1 squared plus y2 minus y1 squared, and then we're going to have to find the square root of that. And this whole thing is going to be equal to root 20. So go ahead and do that. We have the points h minus 1 and 8, 1. So we're going to have x1, y1, x2, y2. Doesn't matter which one you label, it comes out the same. So we're going to have 8 minus h squared plus 1 plus 1 squared. Find the square root of that, and that's equal to root 20. So inside the square root on the left hand side, we're going to have h squared minus 16h plus 64 plus 4 is equal to root 20, and the square root on the left hand side again. We can simplify and we can square both sides all in one step. So we end up with h squared minus 16h, and now we have 64 plus 4, 68, plus 68 is equal to 20. Bring the 20 over, h squared minus 16h plus 48 is equal to 0. Now we have a quadratic here, so we're going to have two answers. We can try and factorize, but the easiest way is just using the minus b. So if we do that, we're going to have our a, b, and c. So we end up with 16 plus or minus the square root of minus 16 squared minus 4 times 1 times 48 all over 2 by 1. We're going to have a positive and a negative. So if we do it positive first of all, if I just look at these answers, we're going to end up with 12, and if we do negative, we're going to end up with 4. So we're going to have 12 or 4. one of these answers is correct. So it's either 12 or 4. So we're going to look back up the question, and it says that A has to be between 0 and 5. 12 obviously is not between 0 and 5. So we can forget about this. So we know that this has to be our point there. So therefore, the equation of the circle is going to be using that. So now we know that our centre is going to be 4 minus 1. So it's going to be equation is equal to, and then we have x minus 4 squared plus y plus 1 squared is equal to the radius squared, which is equal to 20. So this right here is the equation of our circle. Last two questions then. So we have complex numbers. It says write the following complex number in the form m plus ni, where m and n are elements of OR, and I squared is equal to negative 1. Just multiplying out the brackets. 3 by 2 gives you 6, minus 5i times 4i gives you minus 20i squared, minus 5i by 2 gives you minus 10i, and then we have 3 times 4i, which is plus 12i. So we know that minus 20i squared is the same as minus 20 by minus 1, which is equal to plus 20, which is this bit right here. So then we end up with 6 plus 20 minus 10i plus 12i, which gives plus 2i. So then we just have 26 plus 2i. So that right there is our answer. Finally, it says use De Moivre's theorem to write the following complex number in the form p plus qi, where p and q are real numbers and I squared is equal to negative 1. So, how do we do this? De Moivre we're going to have or to the n is equal to the cosine of n theta plus I sine of n theta. So we're going to have or, which is equal to 3 squared plus 3 squared, find the square root, and that's going to be equal to root 18, which is equal to 3 root 2, and then we're going to have to find our argument, which is equal to the tan inverse of 3 over 3, which is equal to 45 degrees. You can do it in degrees or you can do it in radians, whatever you want. Now, when you get to this step when you're doing your argument, we need to check the reference angle. What do I mean by that? Well, we're going to have to plot 3 minus I. So we draw our axes. We're going to have 3 on the real axis, minus 3 on the imaginary axis, so right here. So the angle we're actually dealing with, we draw that right there, is going to be this right here, all the way around. So we can do that, or we realize that when we do the tan function, we found this. So this is 45. So what we have to do is we have to do 360 minus 45. So if we do that, we're at 360 minus 45 degrees, which is equal to 315 degrees. Now we're just going to be plugging in everything. So we can say that 3 minus 3i to the 6, using De Moivre's theorem, is equal to or to the n, so it's 3 root 2 to the power of 6, multiplied by the cosine of 315 times 6 plus I sine 315 times 6. And if we do that, what we end up having is 3 root 2 to the 6 is equal to 5,832. And then if we find the cosine of 315 by 6, that comes out to 0, plus I times the sine of 315 times 6, well, that's 1. Again, it's calculator work. So all in all, we end up with 0 plus 5832 I. And that's the final question there. Hope this helped. Any other questions, just let me know.